Okay, this is a quick little session on the examples from notes 5-2. So we're going to talk about, if I can get that to go away, we're going to talk about just the examples on how to determine if it's a function and then write the domain and range in two types of integral form. All right, so ready, looking at example number 6 here. Let me grab a pen and we'll get started right away. So looking at example number 6, we look at this to decide if it's a function or not. We use the vertical line test. Okay, especially when it's on a graph. So the way the vertical line test is, if I can draw a vertical line anywhere and it touches it twice, and the key is anywhere. I can do it multiple places. If it's just one location, you can tell, that's fine. But I can draw a line anywhere on this, and it only touches this function once. I know I did it 3 times, but I only look at one line at a time. So if this line touches it twice, then it doesn't. It's a function. So I'm going to write down function here. If you look in comparison, here's one vertical line in example number 7. So you look at this right here, touches it once, twice, 3 times. 3 times, that means it's not a function. I only have to draw one line. It fails on one line, it fails overall. So that's why this one is not a function. All right, so let's talk about the bigger part here, which is the domain and the range. All right, here's what I want you to do when you do domain and range. I'm going to clean this off so you don't see all those lines on there. When we look at domain and range, don't forget domain is how far left and right this function exists, and range is how far up and down. We're going to actually go to the graph, and we're going to kind of extend it. I like to extend it. I think that helps sometimes. So we're going to extend this graph a little bit. So both ways, we're extending both ways. But we've got to think of this graph, this function. So here's my line. Right? Remember, this is a continuous function because I don't pick up my pencil, right? It's not a discrete, so we do those a little different. So with this continuous function, what I want to do is think of it as 2 parts. It's moving left and it's moving down. I know that this is moving down and I know it's moving left at the same time. But right now, for domain, we're only concerned with how it's moving left and right. So let's take a look. So I'm going to take my pen and I'm going to dot these little lines. What I'm doing is I'm representing all the possible domains, all the x values that I could go down and see, hey, look, the function's here. And I can keep going, look, the function's here. I can keep going. How far can I go on these domains before I don't touch this function anymore? Remember, that's an arrow, so it keeps going. So that's going to be forever, which we like to say is negative infinity. Okay, so it goes forever. I can go left as far as I want to negative infinity and still find this function. It's going to keep going forever. And then I'm going to do the same thing to the right. How far does this function go? I'm touching all these points. Can I go up and find it? Yep. And I'm going to keep going. Can I go up and find it? Yep. Can I keep going? Can I go up and find it? Yep. All the way out to positive infinity. Okay, we're going to do our domain on the graph first, like I'm doing, and then we'll put them in for domain and range. So now let's switch. Let's do range. So range, then I'm going to start down. How far down can I go before I not find this function? Can I find it? Yep. I'm going to keep going down. Can I find it? Yep. It's going to go down to negative infinity. Okay, same thing going up, checking all these domains, there it is, checking this domain, there it is, keep going, I'm going to check some more domains over there, yep, it's always there. So this is going to go to positive infinity, which brings me then to writing my domain and range. Are you ready? All right, so the domain then, you get to start with the same thing. If we're doing inequality notation first, and that's what we're doing, inequality, okay? So we're going to do interval notation, and we're going to start with inequality, and then 2, we're going to do bracket. You have to do both on your homework for this assignment, okay? So your homework is the worksheet directly behind this, relations and functions, and you need to do both. I'm going to do that in this example as well. So looking at this, you get to start for interval notation, because that's the first one we're going to do. You get to start with a set of fancy brackets. You put an X in the middle with less than signs on either side, and you always start this way, and then we'll tweak it to make it work. Okay, that's how you always start. And for range, same thing, but do a Y in the middle with less than signs and fancy brackets. So now all we have to do is take our pieces of our domain and plug them in to the ends. And then I'll read it to you and explain what it says. So let me switch back to a different color here. So we said that the lowest point we're going to find this is negative infinity. And the highest point we're going to find this on our domain is positive infinity. What this reads as, X is your domain, so we say our domains are greater than all the values up to negative infinity. So it says negative infinity and to the right. And then if we read it again, we say our domains are less than all the way up to positive infinity. So basically it says all the values between negative infinity and positive infinity is our domain. That's what that reads like. And vice versa, or coincidentally, our range is the exact same thing. So this basically says I can find it on every x value for every domain, and I can find it on all the range values. It exists everywhere in the plane for domain and range. Okay. Here's what bracket notation looks like. For bracket notation, really we're going to kind of take out the middle piece here. This just goes away. Right? We assume, if you want to think of it that way, assume that you know that the inequality is there. So we have to do a rounded bracket for this one, and we're just going to say negative infinity and positive infinity. And the same thing for range, because it's the exact same. How do we know if it's rounded, or how do we know if it's square bracketed, right? Because in the notes we'll talk about square brackets as well. Well, if it touches that spot, then it's a square bracket. If it never touches it, like infinity, infinity will always be rounded, then it's a rounded bracket. So let's do another one so that you can. All right, so we're going to take a look at number 8. I'm going to draw a vertical line, pass. I'm going to draw a vertical line here, pass. Anywhere I draw a vertical line, I can draw as many as I want. My goal is to try to make it fail, and I could not draw one on that graph and make it fail. So it does pass, so it is a function. I'm going to change that. It's a little bit big. All right, so now that we know it's a function, let's talk our domain. And again, I'm going to erase this so that we can get a nice clean slate. So looking at the domain, remember it's left and right for domain. We're going to look left values and then right values. So I'm going to take this pen, I'm going to do the same thing I did before. All these possible values, can I find the function? Yep. Can I find it? Yep, it's right there. Can I go up and find this function? Yep. Can I go over here and find it? Yep. It continues on forever. So no matter how far left I go, this function will continue on forever, up and up and up, and it will be there. So that means I go to negative infinity, just like before. Now let's do it to the right. As you can already suspect, no matter how far I go, this function, even though it's going up, will still continue to go to the right, and I will continue to find it. No matter how far along I go, it will always be there. So it goes to positive infinity. This is where it differs. Okay? So we're going to look at the range now. And in the range, I'm going to start tapping down. So all these values here, can I find it? Yep, there it is. You can go down here. Yep, there it is. I'm going to go down at some point, right here particularly. If I go past that point, I can't find the function. It's not there. There's no function. So this is the point at which it stops. Its range has a limit. It only goes down to -4. Okay? Now you're starting to see the difference. And again, if I go up on this one, we know it's going to go up to positive infinity. So let's start to write our domain and our range. So my domain then, here's my set brackets. I'm going to start with those. I'm going to put my x in the middle. I'm going to put my less than signs because I can begin like that each and every time when I'm doing inequality form. Now I'm going to go ahead and put those in, negative infinity on the left, positive infinity on the right. I don't touch them so they don't get equal signs on my less than signs, and it stays like that. Here's where we differ. So let's go to our range. On the range, I'm going to start the same way. Put my fancy brackets in. I'm going to put a y value for range. I'm going to put my less than signs. But this time, I have -4 for my low boundary. And I'm going to put -4 here. Negatives are the lowest values, right, should go on the left. The positive values should go on the right, if they're positive or negative. The lowest should be on the left. The highest should be on the right. All right, so that -4 there, this function touches it at -4, which means that -4 is part of the low domain, so we're going to include it. Where infinity, we can't touch. It never gets an equal sign underneath because you can never have infinity. But I can touch -4. It is touching -4, so it gets an equal sign underneath. On the right side, it goes up to positive infinity, and it doesn't get an equal sign. Well, what's that look like in brackets? Well, let's take a look. So in bracket form, remember we remove the middle. So we just basically take this out, we assume that, and we change our brackets. So again, infinity should be rounded brackets. And that would be to positive infinity. Now we're going to look at this one. This one gets a square bracket because it's included on the left. Remember, it was a less than or equal to. So it gets a square bracket up to positive infinity. So this says that all my domains can be found between basically any number that's real, negative infinity and positive infinity. This one says you can only find ranges up to -4, including -4, because it's got a square bracket. So -4 and up. Anything below -4, negative 4.1111 or -4.0000001, those are not included in my range. Getting it a little bit? All right, let's move down to one more example here. All right, so on this example, check to see if it's a vertical, it passes the vertical line test. Fail on the first one. So this is not a function. All right, going down a little bit further, let's erase this. We're going to find domain and ranges. Now for this domain, look, I can find the function. There it is, there it is, there it is. I can find it here. I can keep going. There it is. It stops right there. That's the farthest that oval is going to go. It doesn't go anything past -10. Okay, again to the right, I can find it. There it is. It's up there. It's down here. It's up there. It doesn't go past -6, I believe. Let me draw that in. It doesn't go past, or +6. It doesn't go anything past +6. So there's my domain boundaries, -10 to +6. So let's check then the range. I'm going to go down. There it is, over here, over there. It doesn't go down past -2. And again, going up, I can find it, I can find it, I can find it, I can find it, up until there, which is +10. So now I've got all those boundaries set up. All I have to do is write them in. Again, inequality first. So domain, fancy bracket, x, because it's domain, less than signs to start. Okay. Lowest boundary then I'm going to find it is -10. Highest boundary I'm going to find it is +6. But it touches both those locations. That oval goes through -10 and that oval goes through -6. So both of these get an equal sign because they are included in part of the domain. So the domain is -10 all the way to +6. All right, what's the range look like? So for the range, it's going to go from -2, touching, to 10, touching. So I get equal signs on both of those inequality signs. What's that look like in bracket form? And again, in your homework, you must do this, both forms. So in bracket, it's going to look like a square bracket for -10 because it touches it, up to 6, and it will also get a square bracket, right? Because it touches it. Same thing here, -2 and 10, both square brackets. All right, so there's your examples. You can see the other ones. Pause the video if you want to see those and write those answers down so you can kind of see in the examples. My teacher notes are also available on the Weebly, on the community, so you can go get those. You can see what I've done. So everything's there. If you have any questions, post them in the community, but we'll work on this again tomorrow as well. All right, thanks for watching.